Good morning, friends. Today I'll continue lecture number 14 of vector. आज के लेक्चर में we'll be doing a scalar triple product and vector triple product. So let us begin lecture number 14, a scalar triple product and vector triple product. So let us begin a scalar triple product. Definition. Let A bar, B bar and C bar be three vectors. A scalar triple product is defined as A bar dot B bar cross C bar. So in this case, first we will take cross product and then we'll take dot product. Why? Because B bar cross C bar gives a vector. A bar is a vector. A vector dot vector is possible and answer is what? Scalar. That is why this product is known as a scalar. Why triple? Because we are using three vectors. So don't forget, first we have to take cross product and then we'll take dot product. So this, some theorems are there. Theorem 1. If A bar, B bar and C bar be three vectors, then prove that A bar dot B bar cross C bar is equal to determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. This means we will write components of first vector in first row, components of second vector in second row, components of third vector in third row. Let A bar is what? A1i plus A2j A2j bar plus B bar is what? B1i plus B2j plus B3k and C bar is equal to C1i plus C2j B3 vectors. Now first, as I told, we will take cross product. Consider B bar cross C bar. determinant ijk b1 b2 b3 c1 c2 c3 will give you I bar into b2 c3 minus b3 c2 minus j bar into b1 c3 minus b3 c1 plus k bar into b1 c2 minus b2 c1. After b bar cross c bar will take dot product with a bar. Consider a bar dot b bar cross c bar. A bar is what? A1i plus A2j plus A3k dot I bar into B2C3 minus B3C2 minus J bar into B1C3 minus B3C1 plus K bar into B1C2 minus B2C1. Now we are taking dot product. So I component will get multiplied to I component. So A1 into B2C3 minus B3C2 minus A2 into B1C3 minus B3C1 plus A3 into B1C2 minus B2C1, and this is nothing but determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. Second one is theorem 2. Theorem 2. For three vectors A bar, B bar and C bar, prove that A bar dot B bar cross C bar is same as B bar dot C bar cross A bar is same as C bar dot A bar cross B bar. Let A bar A1i plus A2j plus A3k B bar is equal to B1i plus B2j plus B3k, and C bar is equal to C1i plus C2j plus C3k. Consider A bar dot B bar cross C bar. We have proved in previous theorem A dot B cross C is what? A1, A2, A3, B1, B2, B3, C1, C2, C3. Now we have to prove A dot B cross C same as B dot C cross A. We will interchange R2 and R1 by property of determinant. When we are interchanging two rows, value remains same, it changes in sign. B1, B2, B3, because we want B dot C cross A. That means B bar in the first row, C bar in between, and A bar at the end. B1, B2, B3. Then A1, A2, A3. And C1, C2, C3 will remain as it is. R1 interchange R2 changes sign of determinant. Now again we'll interchange R2 and R3. R2 interchange R3 changes sign of determinant. So it will become plus C1, C2, C3, A1, A2, A3. Which is nothing but B bar dot C bar cross A bar. So A bar dot B bar cross C bar is same as B bar dot C bar cross. Write this as equation number 1. Again, since A bar dot B bar cross C bar, determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. Now we to prove this is equal to C dot A cross B. C dot A cross B means we want B bar at the end, C bar in the first row and A bar in between. So minus will interchange R1, R2 and R3. A1, A2, A3 will remain as it is. C1, C2, C3 and B1, B2, B3. Reason R2 interchange R3. Again this minus will become plus. Now we'll interchange R1 and R2. So C1, C2, C3 will come up. A1, A2, A3 and B1, B2, B3, which is nothing but C dot A cross B. Therefore, A bar dot B bar cross C bar is same as C dot A cross B. Write this as equation number 2. From 1 and 2 we get A dot B cross C same as B dot C cross A same as C dot A cross B. Next is what? Note. इसमें डायग्राम नहीं दिख रहा है. हाँ नहीं है. ओके. Just I proved A bar dot B bar cross C bar. A bar dot B bar cross C bar is same as B bar dot C bar cross A bar is same as C bar dot A bar cross B bar. So this implies a scalar triple product is a cyclic product or closed product. Hence, it is known as box product and is denoted as box A bar, B bar, C bar. That is A bar dot B bar cross C bar is what? Box A bar, B bar, C bar. Next theorem will be for three vectors A bar, B bar and C bar. If any two vectors be either equal or parallel, then box product A bar, B bar, C bar will be 0. See the proof. Let A bar is equal to A1i plus A2j plus A3K. B bar is equal to B1I plus B2J plus B3K, and C bar is equal to C1I plus C2J, B3 vectors. Case 1. Let any two vectors be equal. So let's assume let A bar is equal to B bar. Therefore, A1I plus A2J plus A3K is equal to B1I plus B2J plus B3K. On equating, A1 is equal to B1, A2 is equal to B2, and A3 is equal to B3. Write this as equation number 1. Consider box A bar, B bar, C bar. Determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. But A1, A2, A3 is equal to what? B1, B2, B3. And this B1, B2, B3 keep as it is. C1, C2, C3. Reason from 1. Now two rows are identical by property of determinant. Its value is what? 0. So box A bar, B bar, C bar will be 0. Case 2 is what? Let any two vectors be parallel. Any two vectors be parallel. We'll assume let A bar parallel B bar. When two vectors are parallel, one of the vectors what is scalar multiple of other. Therefore, there exists a scalar alpha such that A bar is what? Alpha B bar. A bar is what? A1I plus A2J plus A3K. Alpha times B1I plus B2J plus B3K. So A1I plus A2J plus A3K is equal to alpha B1I plus alpha B2J plus alpha B3 K. Now equate them. So this implies A1 is what? Alpha B1. A2 is what? Alpha B2. And A3 is what? Alpha B3. Consider box A bar, B bar, C bar. A1, A2, A3, B1, B2, B3, C1, C2, C3. Now A1, A2, A3 is same as alpha B1, alpha B2. Alpha B3, B1, B2, B3, C1, C2, C3. Now by property of determinant, we'll take alpha outside. So B1, B2, B3, C1, C2, C3. Alpha into 0. So box A bar, B bar, C bar is what? 0. Next is volume of parallelepiped. This is very important theorem. Most of the times they ask in board exam. Yeah. एक मिनट volume of parallelepiped. Volume of parallelepiped. If A bar, B bar and C bar be three vectors represented along three coterminous edges of a parallelepiped, then prove that volume V of parallelepiped is given as V is equal to box A bar, B bar, C bar. See the diagram. ये छोड़ने के लिए बोल रहा है फिर से छोड़ देना, इसमें क्या है, पहले कल जाके आप अपनी तरफ से मत करना, मिलेगा बोल रहे हैं जोगेश्वरी नहीं जाने के लिए, नहीं जाने के लिए बोला भी, कहाँ जोगेश्वरी जा रहा था, हाँ जा रहा था, अभी बोला फिर से बोला कि सर जोगेश्वरी जाना है कि नहीं, हाँ हाँ बोला नहीं, अभी बोल दिया सर, मतलब उसके साथ सुनाई बहुत मिल जाएंगे इसमें उसको, मेरे अच्छे से मिल जाएंगे, क्या करो। This is B bar, this is C bar, and this is A bar. All the three vectors are coming out from one vertex, so they are known as concurrent. O, B, D, C is base plane, and this is A, OA bar. N bar is vector perpendicular on B bar. B bar cross C bar. Draw AM perpendicular on length OM represent height of parallelepiped. Let theta be angle between A bar and N bar. See the proof. Let A bar is equal to OA bar, B bar is equal to OB bar, and C bar is equal to OC bar. Be three vectors represented along three concurrent or coterminous, one and same thing. Coterminous edges of a parallelepiped. Let N bar is equal to B bar cross C bar. Be a vector perpendicular on B bar and C bar. Let theta be angle between A bar and N bar. Theta is angle between A bar and N bar. Draw AM perpendicular on N bar. So length OM represents height of parallelepiped. Volume V of parallelepiped is given as V is equal to, sorry, area of base into height. Now base is a parallelogram with adjacent sides B bar and C bar. Its area is what? Mod B bar cross, and height is what? Length OM. Mod B bar cross C bar is what? Mod N bar. Okay. In right angle triangle OMA, OMA, cos theta is equal to length OM upon length OA. Cos theta is equal to length OM upon length OA is nothing but mod A bar. Cross multiply. So length OM is what? Mod A bar cos theta. So equation 1 becomes, this you write as equation number 1. One becomes V is what? Mod N bar into mod A bar cos theta. Mod A bar, mod N bar cos angle between A bar and N bar, which is nothing but A bar dot N bar. So V is what? A bar dot N bar is what? B bar cross C bar. Box A bar, B bar, C bar. So volume of parallel pipe is what? Box A bar, B bar, C bar. Volume is never negative. If you are getting the sign of box product as what? Negative, that means A bar, B bar, C bar form left hand set of vectors. And if you are getting right positive, then they form right hand set of vectors. Next is volume of tetrahedron. Volume of tetrahedron. Tetra means 4. Hedron means plane. A solid figure which is bounded by 4 planes is known as tetrahedron. If A bar, B bar and C bar be 3 vectors represented along 3 concurrent or coterminous, one and same thing, concurrent edges of a tetrahedron. Prove that volume V of tetrahedron is given as V is equal to 1 by 6 box A bar, B bar, C bar. So this is O, sorry, this is O here. OB bar is what? B bar. OC bar is what? C bar. OA bar is what? A bar. N bar is what? B bar cross C bar is a vector perpendicular on B bar and C bar. Draw AM perpendicular on N bar. Let A bar, OA bar, B bar, OB bar and C bar is equal to C bar be three vectors represented along three concurrent edges of tetrahedron. Let N bar is equal to B bar cross C bar be a vector be a vector perpendicular on B bar and C bar. Let theta be angle between A bar and N bar. Draw AM perpendicular on n bar. So length OM will be height of tetrahedron. Volume V of tetrahedron is given as V is what? Area, 1/3 area of base, because it is tetrahedron. Area of base into height. Now base is what? Triangle with adjacent sides B bar and C bar, which is what? 1/3 times 1/2 mod B bar cross C bar into height is what? Length OM. 1/6 mod n bar into length OM. Equation number 1, reason n bar is what? B bar cross C bar. In triangle OMA, cos theta is equal to length OM upon length OA. So cos theta is what? Length OM upon mod A bar. So length OM is what? Mod A bar cos theta. So equation 1 becomes V is what? 1/6 mod n bar into mod A bar cos theta. Mod A bar mod n bar cosine of angle between A bar and n bar, which is nothing but 1/6 into A bar dot n bar. A bar dot n bar is what? B bar cross C bar. Box A bar B bar. Since n bar is what? B bar cross C bar. Now we'll go to our definition of cross product. Vector triple product. Vector triple product. Let A bar B bar and C bar be three vectors. Then vector triple product is defined as A bar cross B bar cross C bar. Just like section formula, first number we multiply to third point, second number to first points. Same way here. A bar dot C bar. A bar dot C bar times B bar minus A dot B times C bar. A dot B times C bar. And number two is A bar cross B bar cross C bar. Now here single vector is there. So C dot A times B, that is A dot C times B bar minus C dot B times A bar. C dot B or B dot C, one and same thing, times A bar. Thank you very much. Today's quote is, nothing is impossible, nothing is impossible, and everything is possible provided you do hard work. If you are not doing hard work, everything is what? Impossible. Okay? So believe in hard work, do hard work, achieve everything whatever you want. Thank you.